So hi and hello. Welcome to our channel named Algo Exploration. My name is Sami and from today onwards we will going to learn about merge sort. So before going to the merge sort, let me build some intuition that how the merge sort will work and then we will actually start the merge sort. So this is the first question. We have given the two arrays, actually sorted arrays A and B, and we have to merge these two arrays such that the resultant array should be in a sorted order. Let's take an example. Array A of size 4 contains 1, 3, 5 and 7. Similarly, array B of size 4 contains the element 2, 4, 6 and 8. Okay, so the resultant array will look like this. Let's say the resultant array name as C of size 4 plus 4, that will be 8, will contains the element 1, 2, 3, 4, 5, 6, 7 and 8. It is in a sorted. So what will be the first approach to get this solution? Firstly, we will copy all the element of A and B into the C. And then we will sort array C using the bubble sort, because till now we have only learned about bubble sort. Now, for copying the element of A and B into C, will take n plus m time, and to sort the array C will take n plus m whole square. Among this one is dominant, so the time complexity for this approach will be order of n plus m whole square, which is quite huge. Now how can we optimize this? The second approach will be, we will take the help of two pointer technique. This is our question, array A and array B. Now what we will do, we will point P1 as pointer 1 in array of A of 0 and P2 as pointer 2 in B of 0. P1 and P2. Now let me build the array C first. Now what we will do, we will actually compare A of P1 with B of P2, and any of the element is smaller, we will put that element in C. Now among 1 and 2, 1 is smaller, so we will put 1 here and we will increment the pointer P1 because 1 is of now no use. Now again there will be a comparison between 3 and 2, in which 2 is smaller, so we will put 2 here and increment the pointer P2. Now again comparison between 3 and 4, in which 3 is smaller, so put 3 here and increment the pointer P1. Again compare between 5 and 4, in which 4 is smaller, so put 4 here and increment the pointer P2. Now again compare between 5 and 6, in which 5 is smaller, so put 5 here and increment the pointer P1. Now comparison between 6 and 7, in which 6 is smaller, so put 6 here and increment the pointer P2. Now comparison between 7 and 8, in which 7 is smaller, so put 7 here and increment the pointer P1. Now we can see that P1 is actually out of bound, so what we will do, we will actually put all the elements present in array B from P1 to M, in which only one element is present, that is 8, so we will just simply put 8 here. Okay, now let's analyze this approach first. For copying it is actually going to be n plus m as usual. But here what we are doing, we are actually comparing the elements. That will be n plus m minus 1, because let's take this element as 8. After getting compared with 7, none of the elements are present to be compared with 8. Due to that, it will be minus 1. Among this one is dominant, so we will write order of n plus m, which is quite optimized as compared to this one. Now let's take one more example. Array A contains 6 elements from 4, 5, 6, 7, 8 and 9, and array B contains only 3 elements, that is 1, 2 and 3. Now P1 will be at first position of array A and P2 will be first position of array B. Again we will compare array of P1 with B of P2, in which B of P2 is smaller, so we will put 1 here and increment the pointer P2. Now comparison between 4 and 2, in which 2 is smaller, so we will write 2 here and increment the pointer P2. Again comparison between 4 and 3, in which 3 is smaller, so we will write 3 here and increment the pointer P2. P2 is actually out of bound, so what we will do, we will copy all the elements present in array A from P1 till n. 4, 5, 6, 7, 8 and 9. Now in the first example, size of the array A and B are equal, but here the size of the array A is much greater than size of the array B. So there was a situation that the last element of array B is smaller than the first element of array A. Due to that, all the element of array B was being copied first, and then all the elements of array A were being copied in C. So let's analyze this. There will be a case that the situation will array A is smaller and array B is greater. So what we will do, we will check if P1 is still less than n, then we will copy the remaining element of A from P1 to n, and again we will check if P2 is still less than m, then copy the remaining element of B from P2 till m. Let's analyze this situation now. For copy, it is still going to be n plus m, but for compare, now we can see that the 4 is being compared with 1, 2 and 3, and after that none of the comparison happened. So we can say that the minimum of A comma B is the number of comparison happen. So here in this case the dominant is still this one, so we will write order of n plus m. But actually this will be our best case. Now let's see the pseudocode for this merge algorithm. Now this is actually a pseudocode, not an actual code. Now I have named the function as merge, in which two arrays are being passed, array A and array B of size n and n. Now we will initialize P1 as 0 and P2 as 0 and K as 0 for the array C. Now we will check if P1 is less than n and P2 is less than m, then what we will do, we will do the comparison between A of P1 and B of P2. If A of P1 is smaller, Then what we will do, we will put A of P1 in C of K, and we will increment the K and increment the P1 as we seen earlier. Or else if B of P2 is smaller, then we will put in C of K and similarly increment the K and increment the P2, and this is done in the while loop, so it will happen. Now after that we will check if P1 is still less than n. If P1 is still less than n, then we will put all the remaining element present in array A from P1 to n in C. Again, after that, what if P1 is out of bound but P2 is still less than m? Then we will check if P2 is less than n, then we will put all the element of array B from P2 till m in array C, and after that we will return C. And we have seen the time complexity here, that will be order of n plus m. But what about space complexity? It will be still n plus m. How? Because array A of size n and array B of size m, we are actually merging it into a new array C of size n plus m. So the size is actually n plus m, so we will write order of n plus m. Now in the next lecture we will be still continuing the merge sort. So thank you.